Now here we have a triangle ABC. It has two congruent sides, AB and BC. We know the angle B, which is 64 degrees. Inside of that triangle there is a point D, and we also given the length of a segment CD, and angle between AD and AB. And we were asked to find the angle between AB and CD. So how are we going to go about it? Well, first of all, since AB equals to BC, ABC is isosceles triangle. And one of the properties of isosceles triangle is the angles at the base, in this case angle A and angle C, are congruent and they measure equal. Since we know that sum of all angles in a triangle is 180 degrees, we can actually calculate the measures of angles A and C. And that's going to be 180 minus the top angle B of 64 degrees divided by 2, and we get 58 degrees. Now, we know angle A, 58 degrees. We know the top portion of it is 40 degrees. So the bottom portion has to be 18. So the measure of angle CAD is 18 degrees. Let's clean things up. And now what we should remember is the previous video in trigonometry, where I actually discuss angle of 18 degrees, and I show there that sine of 18 degrees is square root of 5 minus 1 over 4. And it looks painfully familiar with the length of this side CD of square root of 5 minus 1. And that makes me think of law of sines. And for triangle ADC. So just to remind you, what law of sines says is if I take an angle in a triangle, take its sine, and divide by the length of the opposite side, this ratio is the same for all angles of the same triangle. So, well, for that triangle ADC, one angle is 18 degrees. Let's call this angle D as Y. And now if you want to talk about law of sines, what we're going to say? We're going to say that sine of this 18 degrees divided by that side CD should be the same as the sine of angle Y divided by the opposite side of AC. This is what we see here. Now, I know the left-hand side. I can calculate it. And from that, I can find that AC is 4 times sine Y. So I relate AC to sine of Y. The next thing is to kind of relate this to something else in this triangle. So far we used the length of CD to get to this point, but we never really use the length of BC or AB. Okay? So let's try to find the length of AC, the side is C, via big triangle ABC. Okay? So let's look at our big triangle. Isosceles triangle, and what we're going to do in isosceles triangle, we're going to draw an altitude, BE. So BE is at 90 degrees to AC. But we know that isosceles triangle has a property that altitude BE is a bisector of the side AC, which means point E splits AC into two equal halves. And also we know that the same BE is bisector of angle B, which means it split this angle of 64 degrees into two halves. And one of them is, well, another one is 32 degrees. And now let's look at triangle ABE. That's a right triangle. And from that triangle, we can find the length of side AE. And that side equals AB hypotenuse times the sine of opposite angle, and that is 32 degrees. So we got ourselves that AE is 2 times sine of 32 degrees. Now, we are not really interested in AE, we're interested in AC, but we know AE is a half of AC. So that let us find whole side AC as 4 times sine of 32 degrees. And now look here, we have AC as 4 times sine Y, and we also have AC as 4 times sine of 32 degrees, which gives us the relationship between sine of Y and sine of 32 degrees. And now the big question is, what is Y? Obviously, there is one solution, that Y equals 32 degrees. That will satisfy this equation. But remember, Y is an angle in a triangle. And angles in a triangle are between 0 and 180 degrees. So if we look at this unit circle, we find that if I have an angle Z, which is the angle between 0 and 90 degrees, it gives me some value of sine, which is the vertical coordinate of point A. But it turned out that this vertical coordinate also is a vertical coordinate of point B, which corresponds to angle of 180 minus Z. So what are we going to say? For pretty much any angle, sine of Z equals sine of 180 degrees minus Z. So in our case, Z could be 32. And as I said, Y equals to 32 degrees is the solution of this equation. But there's also another solution as 180 minus 32, which is 144 degrees. Now, which one of those angles is correct for us? Now, if we go back to our drawing, if we just look at this plot, we find this angle Y just here visually is more than 90 degrees. Okay, and we can say, well, obviously this doesn't work. But let's kind of go formally and let's kind of prove this more rigorously. So the way we're going to go is we're going to assume, well, let's assume that Y is 32 degrees. Now, if you look at triangle ADC, I have one angle of 32 degrees, the other angle of 18 degrees, and the third angle has to be 180 minus 18 and minus 32. And that's going to give me 130 degrees. So, and now I have a problem. The small angle is 130 degrees. But this big angle C is only 58 degrees. Okay, that can be true. And because of that, we have to exclude this answer. And, well, if we exclude 32 degrees, the only other option we have is 148 degrees. So we can say, well, Y is 148 degrees. Now we can calculate this small angle ACD again is 180 minus 18 and minus 148 degrees. And we're going to get 14 degrees. And that's perfectly fine. There's no contradictions. But if this angle is 14 degrees and big angle is 58 degrees, then the angle X should be 58 minus 14 and should be equal to 44 degrees.